last video, I alluded to all of these squiggly braces that you see in the output of the table right here. So let's talk now about what those squiggly braces mean. The squiggly braces are Mathematica's syntax for defining something that is a list. So we mentioned creating a list-like structure, and the elements of a list are then listed together between those squiggly braces. So to summarize one more time, round parentheses are for grouping and order of operations. Square brackets in Mathematica are for passing arguments to functions. And the squiggly braces that you see are for lists and iteration. For instance, if I wanted to create a list in Mathematica, the syntax for doing that would be to provide those braces and then to list the elements that I care about, 0, 0, 0, 1, 0, 2, and so on, between those braces as elements. Thus, knowing this, one thing I could have done, rather than using a table at all, is just patiently list out the elements of my 9-card set deck. The benefit of using a table, of course, is that this is generalizable and moves rather quickly if we wanted to build a larger set deck. The downside to having listed out the elements myself was having to type them. Notice, however, that the number of braces that were output by my table is different from the number of braces I used when I entered the list myself. I have one set of outside braces to indicate the list, and then because I want to group together the 0 and the 0, I put those braces around those two elements to create something of an ordered pair. Remembering that even though I'd write an ordered pair with parentheses if I were writing it on paper, that's not the way I group things together in Mathematica. I've got to use those squiggly braces for that. So the output that I have from my table function contains too many braces. This object that I've created here is actually a set containing 3 elements where it's grouped together all of the cards that have a 0 in the first component as one thing, all of the cards that have a 1 in the first component as another thing or object in the set, and the last element of the set or list is a grouping of all of the cards with a 2 in the first component together. So one way I can solve this problem of what happened with the table was to simply enter the set of ordered pairs myself, but this defeats the purpose of using a programming language. So what we're going to want to use instead is a function Mathematica has called flatten. Let's begin by asking Mathematica about the flatten function, where it gives us again those options for our syntax. We click on the help manual to find some more examples of what's going on here. We see that simply typing the flatten function is going to keep the outermost set of braces and list everything that appears on the inside as one element of that set. That isn't quite what we want, so we'll be looking at this second form of the syntax for the flatten function, which talks about a level at which to flatten. In other words, how many groupings should we take away? If you look at this number 1 being passed to the flatten function here, it goes to the list we wish to flatten, it keeps the outermost braces, and then it gets rid of one level of braces. So around the A and the B, that's everything. So we get elements A and B. And around the element C, set containing D, E, we lose the outermost, just one level of braces. So our elements become C, the set containing D, and E. And a similar thing happens with this third thing right here. Returning to our interactive notebook, let's return to our table here. And now copy and paste, but let's add the word flatten around that table. Again, notice that flattening everything simply makes that list of 0s, 1s, and 2s, but doesn't maintain that one level of grouping that we actually want to see. So if we change from flatten everything to flatten level 1, we get the results we want here with our ordered pairs as elements of my big list, and it matches the work I did by hand to create the small deck object.